Hello, this is 2020. I'm Karl-Emil Kjær Bilstrup, presenting the paper Staging Reflection on Ethical Dilemmas in Machine Learning, a card-based design workshop for high school students. Before we begin, I would like to thank my co-authors, Magnus Høholt Kaspersen and Marianne Petersen, for their contributions to the paper, as well as the Willem Foundation, who have supported this work. We would also like to thank all participating students and teachers. This paper is motivated by the current focus on teaching computational thinking, as well as the way with which emerging technologies such as machine learning is integrated into the infrastructures of our society through smartphones, maps, streaming services, and so on. This development has several implications both on an individual and societal level, but historically computational thinking has not dealt with these, focusing instead on fostering computational skills to young learners. Within computational thinking, a more critical perspective has been gained momentum lately, and it is in line of this work that we find ourselves. We explore how to involve high school students in designing machine learning systems in ways that support exploration and reflection on the technology-close ethical dilemmas inherent to machine learning. When discussing ethics in this paper, we specifically refer to moral decisions made by individuals and organizations, often referred to as microethics. These decisions, made every day by developers, are hidden in software and complex infrastructures, making them difficult to identify and discuss. Through a constructive design research process engaging 4 high school classes, we have explored these aspects, with a card-based design workshop where students design machine learning systems and discuss ethical considerations in a systematic way. The paper contributes with a design rationale for an ethic-first design workshop format, experiences and insights from our constructive design research process, and a discussion of using design processes for teaching students about ethical dilemmas in machine learning. Our approach is based on previous work on design as a learning approach and on card-based design methods. Key work about design as learning is paper's notion of constructionism, which emphasizes a hands-on approach where students learn about technology through creating it. With regards to card-based design methods, these have been found to structure and scaffold the design process and to engage all participants in the design work. The work follows the methodology of constructive design research. In constructive design research projects, knowledge creation is driven by experiments with an exploration of design artifacts. Thus, we see the design of the Machine Learning Ethics Workshop as the main driver of knowledge for this work. For this, we involved 4 classes with a total of 66 high school students in workshop, which included 3 consecutive iterations of the workshop. Through the intervention, the workshop and artifacts were redesigned based on findings from each iteration. Next, we present the final iteration of the workshop. An overview of each iteration can be found in the paper. The workshop is designed to be used in all kinds of high school classrooms, and it is not expected that students have a special interest in or knowledge about machine learning. In groups, students design and describe a machine learning application for helping themselves and their peers in their everyday lives. Halfway through the process, students are challenged with the ethical implications of implementing their application in a real-world setting. To address these implications, they must redesign the application, deal with ethical issues which become more complex as they discuss them, and weigh these against the functionality and user experience of the application. Throughout the workshop, we worked specifically with supervised classification-based machine learning, the kind of machine learning typically used in applications like recommender systems and image recognition. We designed a range of artifacts which are provided to students in different stages of the workshop. There are data cards to analyze a context for different data sources, people cards to analyze a context for potential stakeholders, and ethics cards for reflecting on ethical dilemmas of introducing a machine learning system into a real-world context. Furthermore, there is a machine learning board, which is an A3 poster with a visualization of a supervised machine learning model, with leaving blank fields for students to fill in when describing the machine learning system. The workshop format supports groups of students in designing a machine learning system and in reflecting on the ethical implications of implementing it into the world. It consists of 9 steps. a short introduction to machine learning, a presentation of a case, 6 activities which the groups are asked to perform, joint presentations, and a discussion of the participants' designs. You can find a detailed description of the workshop and a link to the design artifacts in the paper. From the interventions, we found that it was important to support students in describing machine learning systems that conceptually and technically make sense, for the system to scaffold ethical reflections on machine learning. In the first intervention, most groups used machine learning as a magic touch to solve any problem. This did not support ethical reflections well, as the algorithm could just operate in a human and stress-free way. This is a good intention, but does not deal with the underlying technological issues or describe how the group would achieve this. Following this, the machine learning board was introduced. We experienced that students had more detailed discussions about the system's ethical issues. For example, a group designed an app for recommending social groups to lonely teenagers based on their interests. The students were given an ethics card which asked them to question the responsibility of the algorithmic decisions the system made. Based on their design, they were able to have an in-depth discussions about responsibility and who should be blamed if something went wrong. We found that through the design process, students were supported in connecting their discussions about ethics to the designs, and were able to use their discussions in the redesign of their systems. This was, however, less the case in the first workshops. For example, a group of male students designed a machine learning system to rate and sort women according to their breast size. This group did not do well in discussing the ethical issues of their design. They simply answered no, with no further elaboration to the question, is it ethical to implement this? To support students in designing systems that could be meaningfully discussed and were not degrading, we introduced a case about helping lonely students in later workshops. One group designed an app for predicting soon-to-be lonely people and pairing them up with each other. This group discussed the ethics of data collection and the dilemma of the app giving away other people's loneliness by pairing them with strangers. Students struggled with addressing the ethical dilemmas in their designs. Groups who were able to have qualified and interesting discussions about machine learning ethics found it difficult to come up with good solutions to the issues, and often designed systems in which users, themselves and their peers, were responsible for system faults or data collection. For example, one group discussed privacy issues and concluded that users should be incentivized to provide as much data as possible, since this would provide better recommendations. The more lonely they are, the more motivated they become to get better recommendations, as one of them put it. We did not expect students to be able to solve these issues, as even professional designers are struggling with this. Instead, we aimed for the experience to illustrate for students how difficult it is to design and implement technology in the real world. We argue the focus of design workshops should be moved from the possibilities of a technology towards the implications of implementing said technology in real-world settings, when aiming to support critical discussions and reflections about technology. Design processes are typically future-oriented in the sense that we as designers are interested in what could be. However, for a technology-closed discussion about implications, it is necessary to look at the specific here and now issues of a technology. In turn, this implies a change in the criteria for success of such a design process. Instead of focusing on prototyping as an end in itself, we suggest seeing insightful discussions about ethics as a goal in itself, and prototyping as a means to ground these discussions in students' own design decisions. To sum up, we have explored how ethical dilemmas and moral choices in machine learning applications can be made understandable and explorable for high school students. We contribute with an ethics-first design workshop format, experiences and insights from our constructive design research process designing the workshop, and a discussion on how to scaffold technology-close ethical discussions with high school students. Thanks for listening.